All right, so just a quick review of what we talked about last class. We had been discussing pressure, and we came to the definition that pressure is caused by collisions of molecules within the walls, with the walls of a container. So, specifically, what we were talking about was air pressure. All right. So, atmospheric pressure, where you have all these particles that make up the air, your hydrogen, your carbon dioxide, your oxygen, nitrogen, so forth and so on. All these different gas particles that make up the air, which are in constant random motion. So, what they're doing is they are colliding with surfaces. All right. They collide with you, they collide with other things. But in doing so, what happens is that kind of those collisions cause pressure. So the more collisions that you have with a surface, the more pressure that there is going to be. All right. So we asked. So some of the things that we're looking at, we talked about what a barometer was, and how it's used to measure pressure, atmospheric pressure. And then we had also looked at some of the units of measurement and the ratings for standard pressure. So STP, when you see STP, okay, so like when we go back to the beginning here, it said that students know the values and meanings of standard temperature and pressure. All right, so STP stands for standard temperature and pressure. And that is when you say standard temperature and pressure, we're looking at readings at a certain temperature, a specific temperature, and a specific pressure. All right, so that's going to be your STP, standard. And then what we're looking at, so STP, standard temperature and pressure, a specific temperature and a specific pressure. So last time what we had done was we had talked about those specific measurements for pressure. We haven't gotten to temperature yet. So they were, as far as atmospheres, you had what is 1 atmosphere. You have 101.3 kPa. kPa stands for kilo pascals. You have 760 millimeters of mercury. So mm stands for millimeters. Millimeters of, and Hg was the symbol for, the chemical symbol for mercury. So millimeters of mercury, and that's where we talked about the barometer. Okay, so at sea level, what would happen is the pressure at sea level supports a column of mercury that is 760 millimeters high. And then we also had 760 torr were the other ones. So down here, what I went ahead and wrote was I wrote that they are equal to each other, which they are. So 1 atmosphere equals 101.3 kPa, which equals 100 or 760 millimeters of mercury, which equals 760 torr. This is like when we were doing the moles. We said 1 mole equals 6.02 times 10 to the 23rd molecules. And then we would use that to write your conversion factors, right? One thing over another in order to convert from one unit of measurement to another. So you are still doing that, except we're using different units of measure now. We're talking about pressure. Okay. If you have questions, make sure you do let me know. Say them out loud or put them in the chat. Okay, so just it'll be quicker quicker response if you ask me out loud though. So because otherwise it's gonna have to wait until I actually check the chat. Okay, all right. So looking at on your notes we had covered barometer. You had definition of pressure. And then you had those measurements for standard pressure, the 1 atmosphere, 760 millimeters mercury, 760 torr, and the 101.3 kPa. Okay, so this is the part that we had finished in our notes last time. What we're going to do today is we're going to work on conversions. So there was a video, you're supposed to go back and watch the video and work out a couple of conversions. I'm going to show them to you now. Again, not spending too much time on them. They are in the video. So you can go back and look at them. We're going to be working mainly on the third one. So what I did was I put up here what everything is equal to, all right? All the different standard units of measurements that we had for standard pressure, okay? And standard pressure is at sea level. So one of the problems that I had given in the video said given is 4.5 atmospheres, and you are looking for millimeters of mercury. So that's our given. We have a number to start with, and then we are looking for something. So again, this is similar to the setup that you use for your stoichiometry. All right? You start out with your given, 4.5 atmospheres over 1. And then for this, since all of these are equal to each other, we have millimeters of mercury, atmosphere, torr, kilopascals. That means you can set any of these equal to each other, all right, to make up a conversion factor. So when you are doing your pressure conversions, you only need one line, okay? Whatever unit you start with is the unit of measurement that is going to be put down on the bottom, all right? And then whatever you are changing it to goes on top. So we started with atmospheres, okay? Atmosphere is on top, therefore it needs to go at the bottom, times in a line at the bottom of that. We are converting to millimeters of mercury, so that's why it went on top. The numbers that you use are the ones that you have here. So in front of millimeters of mercury, I put 760, and in front of atmospheres, I put 1. All right, and then as you've done your conversion factors before, your calculations, everything in the numerator, everything on top gets multiplied together. 4.5 times 760 came out to 3420, all right? And then it was divided by everything on the bottom, but 1 times 1 is just 1, all right? So the answer was 3420, okay? So the second one that you had in the video was, it was kilopascals, 370.4 kPa, and you were to convert them to atmospheres. So again, you started with your given 370.4 kPa over 1, and then we have one conversion factor, one line. We started with kPa, units are kPa, so we put kPa on the bottom. What you are changing it to goes on top, all right? And then again, where do I get these numbers? Where do I get these numbers here? How do I know what goes in front? Anybody? Where do I get those numbers? Okay, so yes, the numbers that you put on the line comes from the standards which you have, your units of measurement, and the values for standard pressure is where you're going to get those numbers. So ATM, 1 goes in front of ATM, KPA, 101.3 goes in front of KPA. So again, once you have everything set up, we are going to multiply everything on top together. 370.4 times 1 is 370.4. Cancel out whatever units you can, and then everything on the bottom gets multiplied together. 1 times 101.3 is 101.3. Take the top divided by the bottom. So 370.4 atmospheres divided by 101.3 equals 3.66 atmospheres. Okay? All right, now, this one's a little bit different. This one, it says your given is 0.05 atmospheres, and it's looking for PA, it's looking for pascals. We have kilopascals here. And this is looking for pascals, so that's a little bit different, okay? So when you are converting, so think about your metric system. I'm gonna put this, I'm just gonna draw out the metric system for like meter, okay? So if you have, the way that this conversion goes, or metric system is, you have kilo.
Do we write this down in the notes?
All right, so we have kilo, which is represented with a K.
Oh.
Hecto, represented with an H. Deca,
I can't see it. It's out of the view.
and then you have your root word, which is going to be meter, liter, that's an L, and gram. Then we have deci, DECI, centa, and then milli or milli. All right. So each of these are related by a factor of 10. Okay. So when you say meter, liter, gram, this is your root. Okay. So think about a meter stick. Thinking about a meter stick. And what happens is the meter stick can be broken up into smaller readings. So, you know, within a meter stick, 1 meter, you can look at your centimeter marks. You can look at the millimeter marks, which are the smallest, millimeter and centimeter marks, which is the millimeter being the smallest unit of measurement that is in a meter stick. All right. So the way that this works is that this side, these are the large measurements. So meter, liter, gram are your roots. They tell you what you're measuring. Am I measuring length? Am I measuring volume? Am I measuring mass? These kilo, hecto, deca, the ones with the little hyphens on the back of them, deci, centi, and milli, these are prefixes. You stick them on the front of your root words. That tells you how big or small the reading is. So when I say a kilometer, this is the large side. These are really large readings, all right? This is like, instead of talking about inches, I'm talking about miles. If I asked you how far is it to go to Visalia, you would not give me the measurement in inches. You would tell me in miles. It's approximately 10 miles from here to Visalia, all right? All right, so that's kilometers, measuring your length. Okay, that's the largest unit of measurement. Now, milli, so the way, when you go this way, you're getting smaller. This is the smallest unit. You're moving from big to small, okay, when you're over here. And again, everything is related by a power of 10. And when I say that you are relating by a power of 10, that means you are either multiplying or dividing by 10 to move from one unit to another, okay? So when we look at something like Pascal, you have Pascal, and you have kilopascal, kPa. That's a kilo. It's the same thing. You are still using the metric system. So Pascal goes here. This is where Pascal is. Pascal. Okay, and the abbreviation is capital PA. And then you have, again, kilo over here. So would Pascal or would kilopascal be bigger? This is like me asking, is meter, 1 meter, or 1 kilometer bigger? Which one's bigger? A meter or a kilometer? A Pascal or a kilopascal? Which one of those is the bigger unit of measurement? Go ahead and put your answer in the chat. Good, it's going to be kilo, okay? So that tells us that what happens is when I say 101.3 kPa, kilopascals, okay, your pascals, when you're just looking at pascals, you're going to have a lot more. The way you do this is wherever I'm starting, if I have kilopascals and I want to know how many pascals there are, whichever way you're moving on this chart from your start to your to where you're ending up, that is the way that you are moving your decimal. Okay, so for example, if I had um, 1.5 kilometers, and I want to know how many meters this is. If I had 1.5 kilometers, and I wanted to go to meter, I want to convert kilometers to meter. The way that I would do this is to get from kilometers, that's where I'm starting, that's my given, to meters, I have to move to the right on this chart. How many spaces do I need to move over to get from kilometers to meters? How many spaces do I need to move over? How many?
3.
3, good. So
3.
you need to move 3 spaces. So the way you do this is my decimal, wherever it is in the original number, I'm going to move it in the same direction. So if I had to go from kilometer, the units, to meter, if I have to move 3 spaces to the right. Then for the number, I am also going to move it 3 spaces to the right. So 1.5, and that means you're multiplying by 10. When you move it to the right, you're multiplying by 10 for each space. So I said move 3 spaces to the right to get to meter. I need to move my decimal 3 spaces to the right. Each number counts as a space. There's 1, 2, 3. Well, there are no numbers here, but this is where my new decimal is supposed to be. So I fill it in with zeros, all right? We just moved our decimal. So that means as far as this, 1.5 kilometers equals 1,500 meters. Okay? So whatever way you're moving on this chart is the way you need to move your decimals. So let me give you another one, but I'm going to ask you about pascals. What if I have 0.03 kPa and I want to know how many pascals there are? I want to go from kilopascals to pascals. Okay, so remember kilo is right here. It doesn't kilometer, kiloliter, kilogram, kilopascals, all right? Kilojoules, measurement of energy, all right? So we have it here and we need to go to pascals. So which way am I going to have to move my decimal? To the left or to the right? To get from kilopascals to pascals. So kPa to PA. Have to move to the right. How many spaces? 3. Okay, good. So we're going to do the same thing. So my 0.03, moving it 3 spaces to the right. Remember, each number counts as a space. Is 1, 2, 3. If I have a blank that doesn't have a number, I fill it in with a 0. So this decimal is gone. This is where my new decimal is. So as far as pascals, 0.03 kPa is 30 pascals. Okay? So when I have a problem like this one, it says I need to convert 0.05 atmospheres to pascals. What am I going to do? I am going to use this conversion. I'm going to convert to kilopascals first, and then move the decimal to convert to pascals. All right? So we have 0.05 atmospheres. We're back to this problem. So remember what we're going to do is we're going to change 0.05 atmospheres. We're going to change it to kilopascals first. Okay, I'll put that up here. So change to kPa first. And then change kPa to PA just by moving the decimal. Again, we're going to change ATM to kPa first. And then once we have the kPa, we're going to change the kPa to PA just by moving the decimal 3 spaces to the right. Does anyone need this? Write this down. Anyone need this before I move the page down?
Go down a little bit.
Does anyone still need this part?
Me.
All right, so let's go do this problem down below. We start out with our given, which is 0.05 atmospheres over 1. And we have our conversion factor. Remember, we're changing our ATMs. ATM's on top, so it goes on the bottom. We are changing it to kPa first. Okay, what number goes in front of atmosphere? What number are we going to put in front of atmosphere? 1, thank you. And then what number do we put in front of kPa? Good. So we're getting the numbers from up here. Atmosphere has a 1 in front of it, and KPA has 101.3. All right. Multiply everything on top. Well, let's cancel out the units first. ATM on top, ATM on the bottom. We can cancel that out. And then we have 0.05 times 101.3. Multiply everything on top together. And that comes out to 5.065 KPA. And it's 1, on the bottom it's just 1 times 1, so divided by 1 still comes out to 5.065 KPA. But remember, they are not asking us for the answer in KPA, kilopascals. We're supposed to convert to pascals. So how do I change this KPA? How do I change it to pascals? What do I need to do? What do I need to do to change KPA, kilopascals, to pascals? What do I need to do?
Move the decimal 3 times to the right.
Good, thank you. So kilopascals is here, pascals is here. To get from kilopascals to pascals, I would need to move to the right 3 spaces or 3 times. So you're going to do the same thing to this number, 5.065. Take your decimal, move it 3 spaces to the right. So the answer in pascals is 5,065 pascals. Okay, and then make sure to box your answer. Okay, so I'm going to actually go ahead and pause this here. We'll take up the temperature next time. I'm going to go ahead and give you the problem so that you can get started on those, your pressure conversions. That way you can ask me questions in class. Make sure this is done by tomorrow night by 8 p.m.
Can you show the top of your paper